now study capacitors in parallel. So capacitors we learned can be connected in different ways. Okay, first we learned series. Now we learn capacitors in parallel. So let me draw it for you. Now I'll draw like this way. So first we'll take a cell here. Okay, this cell here, this is positive and negative. Then like this way we have the rails here. Like this way. Then you connect three capacitors now. This is the first capacitor. Capacitor is drawn by two equal lines. This capacitor I marked as C1. Then this is second capacitor C2. Then we have a third capacitor, that is C3. Okay. These three capacitors are connected in parallel. You can see that they are parallel to each other. Now what happens is, as the battery gives a voltage V, okay, and there's a charge coming here. Okay. So these plates will become positive and this will become negative. So top always becomes positive here, the bottom one becomes negative. Okay, the voltage is constant here, but the charge will change. Okay, the charge here on the first capacitor will be different from charge Q on second capacitor, and then from the charge on third capacitor. Okay, now instead of drawing three capacitors, the circuit sees as if there is just one big capacitor in parallel. Okay, so let's see that now. So I'll draw the cell here. This is a positive and negative. Okay, voltage is V. Then instead of having three capacitors, we just draw one capacitor having an equal capacitance Cp. Okay. Capacitance in parallel. Okay. Let's now see this. Here. Now we said this first. The voltage is constant here. In a parallel connection, voltage is constant. So the voltage V is constant in this case here. Okay. Then what happens? What will change here? Charge changes. Okay, so the total charge Q is equal to, each capacitor will have different charges now. We can write as Q1 plus Q2 plus Q3, because each capacitor will store different charges. Okay, now we must get the formula for charge now. Okay, but we know the formula for capacitance. So capacitance formula, that is C is equal to Q by V. Cross multiply this V upwards. Okay, so what, and rearrange. So we get here Q is equal to C into V. Now I'll use this in here. Okay, so instead of writing first one, we can write as Cp into V. Why? Because in this left side we can, or in the left side you can see, we have one big capacitor Cp, it's equal to one big capacitor Cp, and then the voltage V. And right side will have C1 into V plus C2 into V plus C3 into V. Okay. Now what is common here everywhere? V is common, we'll take it out. So V into, we have a Cp equal to, then this side we'll take V outside, V into C1 plus C2 plus C3. Okay, cancel the common terms, V and V cancels. So it here Cp is equal to C1 plus C2 plus C3. Okay. So what does the equation mean? So capacitance in parallel is equal to sum of the individual capacitances. Okay, that means the total capacitance will be more than the individual capacitances.